Hello everyone, this is N. Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. Today I will be explaining the concept of interrupts in 8051 microcontroller. So coming to the overview of today's presentation, what are the interrupts present in 8051, how interrupt service routine will be there in 8051, the interrupt vector table, and what are the special function registers interrupt enable, how to enable the interrupts, how to prioritize the interrupts. Okay, yes, coming to the interrupts. As you all know that interrupt is a program that temporarily halts the execution of the main program or disturbs the execution of the main program, right? So there are before interrupts concept, there are another concept that is polling, right? Polling. So first of all, the devices that having all. So if the controller is here, this controller will check for the interrupt in this sequence, round sequence. Okay. So now first it will check here. If nothing interrupt is there, then it will check here. So if interrupt is there, it will execute and then it will check here, and like this the concept will be. So it is the waste of the time of controller. So if any external interrupts or any interrupts occurs, then only the controller can able to access that interrupt. So that's why this interrupts concept has been evolved. So here there are two types of interrupts. First one is hardware interrupts and the software interrupts. The hardware interrupts are the interrupts that will be triggered by the external sources or external signals. Right? Software interrupts means that interrupts are written in the instruction itself by the programmers. Right? Yes. In 8051 there are 5 interrupt sources are there. Reset is also one of the interrupt, though it is having the highest priority. And the remaining 5 interrupts are 2 external interrupts are there, INT0 and INT1. 2 timer interrupts are there, TF0 and TF1 timer interrupts, and 1 serial communication interrupt is there. Okay, that is TS. So how these interrupts are there, how we will enable or how we will utilize these interrupts, and which interrupt is having the highest priority, we will see. Right? Yes. So the first one is interrupt service routine. What is interrupt service routine? Interrupt service routine is a special function that the how microcontroller will be executing the interrupts. So the structure how microcontroller will respond while executing the interrupts. Okay. So while executing the interrupt, if any the controller is executing one program, right? So if the controller is executing one program, it is in the instruction n, and the next instruction is n+1, so on. If any interrupt occurs while the controller is executing the nth instruction, so how the controller will approaches the interrupt, how will it resolve the interrupts, like that. So now if the first controller is executing the nth instruction, if any interrupt occurs, then the controller need to complete the execution of this nth instruction. It will complete the execution of current instruction. Okay, so it will execute the continuation of main program is running, interrupt occurs, so it will continue the execution of current instruction. Then so it will pause the execution of the main program, and it will save the flag registers, the addresses of stack, all in the stack memory. So it will store the data. So if the controller need to execute the next instruction, it need to have the address of the next instruction. So that's why the flag registers, the important addresses, all these will be stored in the stack for temporary purpose. Now the controller will go to the ISR. So where the controller, okay, now the interrupt occurs. If the interrupt is timer flag 1, consider flag 1 interrupt occurs. So how to find out the timer flag 1 interrupt? So that's why there is a concept known as interrupt vector table. So what is the interrupt vector table? In every controller, the first memory locations will be always loaded with this interrupt vector table. This vector table have the addresses of each interrupt present in that microcontroller. So the controller will go to the interrupt vector table and find out the address of that particular interrupt. So then it will go to that particular address and it will execute that particular interrupt. So how it will get back to the main program from that interrupt? If the controller after interrupts ending, the controller need to check the return I, RETI. So this return I instruction means return from the interrupt. So it will return from the interrupt, and while getting back to the main program, it need to have the address of the next instruction, right? So to find out the next instruction, the in the second step, it's already stored in the stack, so it retrieve the data from the stack to the respective registers. So then it will find the next instruction address and it will execute the next instruction. So this is the structure how the microcontroller will perform if there is any instruction occurred while executing the program. So this structure is known as how the controller handles the interrupt. This structure is known as interrupt service routine, right? Yes. Coming to the interrupt vector table, as I already told you that in 8051 there are 5 interrupts, and most of the cases 6 interrupts. The first one is always the reset. It is having the highest priority, but the remaining 5 interrupts are external interrupts are 2, INT0 and INT1, and the timer interrupts are 2, TF0 or TF1. TF0 is the timer 0 flag, and TF1 is the timer 1 flag, right? Yes, and then fifth one is the serial interrupt. Receive interrupt will be there, transmit interrupt will be there. Both will be considered as only one interrupt. So these are the 5 interrupts, and this is the structure that priority is there. So the first priority always go to the external interrupt 0, and the second priority is for the timer interrupt 0, and third priority is for external interrupt 1, and fourth priority is for timer interrupt 1, and the fifth and the last priority is for serial interrupts. Okay, so this priority is very important, because if executing the program, there is 2 interrupts occurred at the same time. So which interrupt need to be executed first? So it always depends upon the priority. So if any interrupt, like if we are having timer interrupt 0 and serial interrupt, at a time we are having 2 interrupts. So which interrupt need to be executed first and which interrupt is followed next? So it always depends upon the priority. According to the priority here, the first TF0 timer flag interrupt 0 will be executed, and after executing this, then the serial interrupt will be executed. In some cases, if we want the priority levels change, so how we will change? There is one special function register, that is interrupt priority. IP register is there, right? So by using that, we can set the priority levels. Okay, yes. So there are 2 special function registers in special function registers in interrupts of 8051. Those 2 are IE, interrupt enable, and IP. So interrupt priority. IE is the register which enables all the interrupts, and it can access it or it can resets the interrupts. So, and IP is the interrupt priority. This register is used to set the priority levels. So if we want the priority of that particular interrupt first, you can set by using this IP register. Okay. Yes, coming to the IE, interrupt enable register. Here, interrupt enable register is a 8-bit register. So it is a 8-bit register, and here the first bit D0 is EX0. It is external external, so INT 0, so which is external 0 interrupt. This is external 0 interrupt, and this is external 1 interrupt. I have already told you 2 external interrupts are there, right? So this is external 0 interrupt, and this is external 1 interrupt, and this ET0 is timer 0 interrupt, and here ET1 means timer 1 interrupt, and ES means ES means serial port interrupt, serial communication interrupt, either TI or RI, right? Yes. So if we want to enable this ES interrupt, first of all you need to set this interrupt is not present in 8051, it is used in the other versions of 8051. So here EA means enable. So enable interrupts, interrupt enable. So if this bit is 1, then only any one of the interrupts out of 5 interrupts can be enabled. If this bit is 0, so nothing is there, no interrupt will fetch the 8051 microcontroller, right? So here, the first one, EA is 1, then it enables the interrupts. If it is 0, all the interrupts are disabled. And here, if we want to enable ES interrupt, then IE4. So in this one need to be set to 1. If it is 0, serial interrupt will not be accessible. So here also everything is like that. So E1 is external, enables timer 1 interrupt. This is timer 1 interrupt. This is timer 1 interrupt, and this is timer 0 interrupt, overflow flag interrupts. These two are external interrupts, right? Yes. Coming to the next register, it is interrupt priority register. This register is used to set the levels of each interrupt. So which interrupt is having the highest priority or which interrupt is having the lowest priority. You can utilize the interrupts. So here one thing is there, that the low priority interrupts can be interrupted by a interrupted by a high priority interrupts, but not another low priority interrupt. Suppose if we are using higher priority interrupts, you can use a lower priority interrupts, but only two low priority interrupts will not be occurred at a time. So if interrupts are of different priority occur simultaneously, the highest priority interrupt is served first, as I already told you, right? Yes, if interrupts of same priority occurs at the same time, the internal polling sequence decides which interrupt is handled first, right? Which interrupt came first, or which interrupts need to be handled first, like that. Right. So next is this IP register. So here PS is the serial port interrupt, T1 is the timer 1 interrupt, X1 is the external 1 interrupt, PT0 is the timer 0 interrupt, and PX0 is the external 0 interrupts. So this is the priority. So if we want to set priority for the serial port interrupt, then we need to keep 1 here. Okay, if we want to set that priority for timer 0 interrupt, we need to keep here 1. The remaining all the interrupts need to be disabled. Zeros we need to keep. Let us see how we will do. So here they have given one question, that what value should be loaded into the interrupt priority. What is the value we need to load into the IP register to assign high priority to timer 0? So timer 0 interrupt means here, right? PT0 is the timer 0. So here we need to keep it to keep priority for timer 0, we need to keep it as 1. So next, and serial interrupt. So here also we need to keep 1. And while keeping all other interrupts at low priority. So the remaining all need to be low priority, right? Write the corresponding assembly instruction. So how we will load this value? So here also 0. So the values of these. So the corresponding hexadecimal value of 0001 is 1, and the value of 0010 is 2. So how to write a instruction? How to load this instruction? There are many types we could use, like move. This is the IP register. So IP, comma, hash. So here we are having 1, here we are having 2, and this is hexadecimal representation. Or how can we write directly the bits itself? So you could use move IP, comma, right? Yes, hash 0001 0010B. So here if we are mentioning B, it is a binary. The same numbers you could use. You could use decimal numbers also. Or else you could use two instructions. So set bit, this one is bit 4, right? So IP dot 4. So it will enable this one. So or else you could write set bit IP dot 1. So it will enable this one. So this is how we will enable. So these are the instructions used to enable or disable the IP register, right? Yes. Coming to the next one. Here what they given. So given the instruction move IP 0 0 0 0, right? Yes, 0 1 1 0. B means binary, right? Next one. Which interrupts are assigned high priority? So according to the instruction given, which instruction having the high priority? High priority is given to the bits that is set. So here what is this? PX1 means external 1 is having the priority, followed by timer 0 is having the next priority, right? Yes. So now what is the priority level of the remaining interrupts? So first of all, the priority level is first the here PX1 is PX PT naught is having the highest priority. So the PT naught will executed first, then followed by PX1. The remaining else will be followed by the priority list. So it will be followed by PT1, next PS. So sorry, here PX naught will be there, next PT1 and PS. The remaining else will be followed as per their priority list that I have already discussed in the first slide itself, the priority of the interrupts, right? So this is how the interrupt priority and interrupt enable registers will be used, right? So until now I have discussed what is a interrupts, how many types of interrupts are there, how many interrupts are there in 8051, and what is interrupt service routine, how we will store the interrupts addresses in a interrupt vector table, and what are the priorities of interrupts present in 8051, and how we can choose the priority of the interrupts by using IP register. Thank you.